This is going to be a bit of a technical one, and while I don't want to discourage anyone from following along, if you don't have much experience with geometry nodes, it's going to be tough, because I'm not doing it as a regular kind of tutorial. I'm doing it more as a breakdown where I show you around the file and show you how it works. But I have put the file up for download on my Gumroad. You can download it, poke around, see how it works. And if you do want to follow along, you're more than welcome to. By the end, you will have all the information you need to build the system yourself. Okay, so this is the scene. It works by placing 3D objects like spheres between the camera and the light source. And when you move the camera around, you'll see it also moves the lens flare around. And the same goes for the light. You can move the light as well. And if you move the light behind an object like this cube here, you'll see that it gradually starts to fade out the lens flare. So it's not abrupt, it's gradual, which feels a bit more natural. And you have a bunch of control over this rig. It's quite versatile. I'm guessing I showed a few examples in the intro. So I'll just show you around the file so you get an overview of how it's made and hopefully enough info to make one yourself. Okay, so this is the most basic version of the thing. Actually, if I turn off the bloom and the curves and also the compositor, this is the most bare bones. So what you see here is the basic rig. When I move the camera around, you'll see this empty moves around as well. So this is the skeleton of the whole thing. This is built with a combination of geometry nodes and constraints. So this is the GeoNodes rig. It's actually quite simple. The first thing it does is it places one point right between the light and the camera. And this empty is parented to that point. You can see here in relations, this has a vertex parented to one point on this line. And this line looks a bit buggy because of the order of operations thing. You'll just have to update it like this, and it pops right back into place. Now this one is constraint based. So this copies the location of this empty in the camera's space. So if you just copy this setup, so that ensures that wherever this point is, this point will always be on the opposite side in relationship to the camera. And then finally, this line is drawn to that point. So it kind of goes back and forth between the empties and this GeoNode setup. But this is what it looks like. And it's more complicated than it would have to be because of this part, which is to handle both a point light, which is this, and a sunlight. So what you can do is go into the modifier panel of this rig and you can press use sun. And then it will no longer be based on where this point light is. Instead, it'll place this point on the sun's rotation vector, because obviously, if you just pull this towards the sun object, that's not going to look right, because the sun can be anywhere in the scene and it'll look like it comes from the same direction because it's infinitely far away. So this doesn't work on the same principle. It copies the rotation vector and converts it. So this is how that works. And now for the rendering, let's just see how far we can get for free. So for one, we're in Eevee, so we can turn on bloom. This is the first layer of just free effects that we don't have to work for. Second one, curves. This is how I like to colorize, because this curves layer works on the whole composition, so you can colorize the whole thing in one go. So all I did here was pull down the R a little bit, the red channel, which makes it cyan. But we can pull that up instead, which will make it redder. And we can pull down the green, for instance, which will make it a little bit purple. And this is a really natural way to colorize the lens flare. And now also let's turn on the viewport compositor. It's simple enough. It has 4 nodes, a blur, which is set to Gaussian. All that does is this. It blurs it out a little bit, which really helps with small light sources. That, and also in the camera I do depth of field. This is focused on rig point 1, which is this. Also in here I've added a glare, which is a streak. A glare, which is a ghost, that's set to 0 by default, but what that does is it does this, which I think is kind of ugly, but it's there. And a lens distortion, which is kind of weak, but it looks amazing. I think it looks great near the edges. But you have to be really careful with this because, as you can see, it does move the light around. So if you don't use the same lens distortion on your original scene as you do on this, then things won't line up. Which brings me to how to actually bring this into your scene. And what you'll have to do is you have to copy your light source and your camera into this scene right here and parent this camera to that and this light to the light, and also add in occlusion objects, which is in my occlusions collection. And then the camera's animation will be driven right here, and things will probably, hopefully, line up for you. I've added a couple more features to the rig, specifically the distance to camera, which is this. If you want to place things closer to the camera, that can be very useful. And the light size, which is the physical size of the ball. And this ball moves from this point light to the sunlight. If I change it to use sun, that moves the ball up there somewhere. Yep, that's it. Which is just an emissive ball, which works with the EV bloom. And also how I do the occlusion hit scanning, but we'll get to that in just a bit. Now all of these elements here are built in geometry nodes, and they use some custom nodes that I've made in the Flare Composer object. Let's make our own from scratch. Let's duplicate this joined geometry node and bring that into here, which brings us back, right, to this default stage. All of this is the flare that I made earlier. And each flare element goes into here. So these are the 4 nodes that make up a lens flare. They are custom nodes. So let's start by placing one of them here. We'll start with the 2D lens element. Just bring that into here, and there we have an element. Now the element has a bunch of settings. The most important one, let's just reduce the radius of this a little bit, is the placement. Now the placement places the point along this line. A placement of 0 is exactly above the light, and a placement of 1 is on the exact opposite side, and you can go beyond 1 and you can go beyond 0. And so you can imagine that if I stack a couple of these on top of each other and give them different placements, like so, we can begin to make a nice looking lens flare. So in the geometry tab, we have the obvious radius. We also have the number of blades, which I usually, what's smart to do is here, if we have 2 of them right next to each other, we can do a value which goes into both of these to make sure that they always have the same number of blades, because that's how it works in a real camera, right? All of the elements come from the same lens, which has the same number of blades. And if you want to round out those blades, there's the round edges, which goes all the way to the top where you have a circle. And obviously you can rotate it around. You can also offset it in space, just left and right and top to bottom. Now in the color tab, you have the basic brightness of this element. It's smart to keep it pretty subtle, because when these things stack up, they become pretty noisy. Random brightness, we'll get to that. There's the color, which tints it. and the spectrum, which works with some of the other settings further down. I'll show you that. Random hue for later. Glint gives it. Well, you know what? We'll do that together with the next setting as well. So the edge fade. This one is very interesting. Let me place this further towards the middle and make it a bit bigger. Now the edge fade, right now it's a constant color from start to finish. I can't draw on this, hold on. From start to finish, there's a constant color. If I change the edge fade to 1, now we have a gradient going from the middle on out. It's very subtle. We can increase the brightness. That's what that looks like. It's just a basic glint. We have the edge fade version 2, which is a circle. Version 3, which is more a donut, and you can change the inner radius, you can change the outer radius. And the last one, which is more of a sphere. Now the glint works really well with version 3. And if I turn up the glint now, and the spectrum, you'll see we get a really nice looking rainbow. And there's also edge jitter, which pulls in the edges to make it look a bit more like an iris. So here we have a normal fade, and this just pulls it in to make it jagged, right? Distortion. That changes the shape based on where it is on screen. So let's... If we place this along the edge, like this, make it smaller again. It's a bit of push and pull right now. You'll see that it will elongate towards the edge. The anamorphic basically just flattens it. And the edge grow is how much does it grow towards the edge. So when it moves towards the middle, it's small. When it goes towards the edge, it's bigger. That is the 2D lens element, and it works really well with one of the other nodes, which is an array. The array basically just spawns a bunch of these along that line, which is a very quick way to make more of them. And the array has a couple of unique settings. You can change how many, you can change where they are, and this is where the randomness from this node comes in. If you change, for instance, the random hue on this, they will each get a random hue, which is a very good start to our lens flare. In fact, what I usually do is I start with a basic glint. So let's do that. That was the edge fade version 1. We make it very bright, very big, place it exactly on top of that. It has a random hue. Let's turn that off. Let's make it brighter, bigger. Well, not that bright. Just to have a basic haze going over the scene. That looks pretty good to me. So that's before and after. Just adds a bit of glow. And then let's add an array. I'll make all of these a bit smaller. Let's place it on 0, which makes the array work a bit better. Give them a random position, each of them. Increase the count, maybe. And bring them out. Let's use this to enhance that line, to just really demarcate it. And make each of them a little bit bigger. Not as round. And a lot less bright. Less random hue, so they're not as colorful. And just change the random seed until I get something that I really like. I think this is great. This is a great start. Just to enhance that line, to show you where that line goes. Now that we have a glow and a line, let's add one of those glints that I showed earlier. I'll change it to edge fade version 3, add a glint, increase the brightness, add a spectrum, and make it big. This is really nice to have right around the light. So let's decrease the brightness to make it a little more subtle. I still want you to be able to see it. And then change the random seed until I get a glint that I really like. Now that I feel like it looks nice. And just turn down the brightness of that. Because in movement, you'll see it more prominently anyway. Now one cool thing, this thing also looks really good if we place one at placement 1, which is the opposite side, and just make it very big. That kind of counterbalances it. Let's see here. Let's see. Let's actually pin this window so as I stop losing it, and increase the brightness of it, just so you see what I'm talking about. Look at that. It just adds a bunch of color and movement around the edges. So let's just refine that a little bit, change the random seed until I get one. Yeah, that's gonna work. And turn down the brightness a lot. So it's just barely visible on the edge there. It only really shows on the right side though, so let's change that again until we can see it more on each side. There we go, yes! That's great. Now for the start of the show, we'll add one of the other custom nodes here, which is the 3D lens element. So far we've been doing 2D ones. Let's do a 3D lens element. It has a lot fewer options, it's less complicated. I'll just place this along the middle, and you'll see it working its magic. What this is here. It's this sphere right here, the 3D sphere, and it's interacting with a light that is right here. That is the emissive light from the rig. Those are interacting, but it looks like this kind of crescent shape. And when the light goes to the middle, you'll get the circle. And so this has the kind of caustic look. And all you really have here is the brightness and placement and size of it. And most of the settings for this is in the material. Now for some texture, I'll add the final node of this lens flare, which is going to be the lens orbs. Lens orbs. And the lens orbs are, they're this. They're, hold on, let me show you just those in isolation. So you just have some scattered circles, and they're parented to the camera, so they move with the camera, which means that in this view, it looks like they're just plastered onto the camera, but they light up in proximity to the light, so they are here to simulate dirt on the lens. Now, how are these nodes set up? It's actually very simple. It'll look intimidating at first, but I promise it's not that complicated. Let's go into the 2D lens element first. So it's just a long chain of things happening. If we go to the start, this is a curved circle. It's making the lens element, right? The radius of it comes from this size calculation here, which basically takes the two rig points, which are the empties I showed you earlier. It's this and this. And so it's calculating the distance between those to increase the size if you have grow towards the edge enabled, right? That's what that is. It's filleting, it's filling it, and then I calculate a UV map on it. I give it a random value that I can use later. It takes the rotate value and just rotates it, you know. It also rotates the thing relative to the camera, which makes it always point at the camera. I have a custom node group here, which is a placement vector, which basically it calculates the direction between the first and the second rig point. That line between those, that's the vector that pops out here. And I just set position along that multiplied by the placement, right? I elongate it. This is the elongation group. You can copy that if you want. And then I squash it and offset it and set a material. That is the basic thing. This is the basis of making the geometry for the lens element. Most of it is done in materials. And to make the geometry nodes communicate with materials, that is what this is doing. I want these sliders here to control shader nodes. So all I'm doing along this whole chain is storing a bunch of attributes, just plugging from group input into an attribute. So like here, I take the color slider, I store an attribute called color. I take the edge fade slider, store it into an attribute called edge fade. And that's all of this is doing. And in turn, all of this is read in the shader nodes. So if I go into the shader editor, into the lens material, inside of this shader here, forget what's happening on the outside for just a moment. On the inside, this also looks complicated, but all of the nodes, all of these groups are doing one very specific thing. So for instance, up here in the coloring, I get the color attribute with an attribute node. That is the color exported from the geometry nodes that we just saw. And it's going into here, multiplying with all the other colors, right? And the same thing happens with all of these attributes. I get the glint attribute, right? Which mixes in the glint from here. And all of these are very predictable. You won't learn much new things here. Maybe this part, which calculates polar coordinates based on the UV. So a UV map, right? It goes U and V, and that is the map. But a polar coordinates has a circle like this and a radius. And the U goes around the circle, while the V goes along this line. So you make the UV coordinates circular, which is what calculates, for instance, the glint, right? This spectrum thing, which is here. You just plug these polar coordinates into a noise texture, which gives you that spiky noise going from the middle and out. It also drives this here, which is just a color ramp. HSV set to clockwise gives us the spectrum. And when that radius coordinate goes into here, that is what gives us the spectrum, which looks like a bullseye, you know, going outwards like that. That is the other segment of that vector. These are the versions of the edge fade. This is the edge fade attribute, which is, that's the integer set to 1, 2, 3, or 4. Which one do you want? And each of these is looking for 1, 2, 3, and 4, and using that to mix between either this pipe, or this pipe, or this, or this. And these are basically just different ways of fading along this axis, this radius axis. The edge jittering, you can just copy this as well, is multiplying a noise into the color and then clamping that afterwards, which is distorting it like this. All of this is mixed together and at the end just added to a shader. And the shader is an emission added with a transparent. And then at the end, we also mix in transparent if it is back facing, because that allows light to penetrate through the back of each element so that they don't occlude each other. And on the outside, you get some global controls. So you get the global tint, for instance. You can add blue to everything. Let's do that. And you can change the global brightness of every element. I control the global brightness using this distance value, which is the distance between this empty and this empty, so that when they are close, meaning when the camera is looking straight at the light, it's going to be high, and opposite when they're far away, so that looking straight at the light makes everything a bit brighter. And also we multiply everything by the occlusion so that everything turns off if the light moves behind a wall. And I'll show you that in just a moment, but first let's just go through the other materials. The 3D lens material also has a brightness control, just like the previous one. It has a color. Well, let's change that color to match everything else a bit more. and it just has a roughness and an anisotropy slider. And you just really have to worry about the roughness. It's just controlling. Inside here, there is a glossy BSDF, and that's all there is. It's a glossy, you control the roughness of it, it's reflecting that light behind here, and it's going into a shader to RGB so that I can control those RGB values with other sliders. So this is the whole shader. It's really simple. And the lens orb material is even simpler. It has a random value, which just adds a random brightness to each one. It has a distance, which controls the distance from the light. And other than that, it just looks like everything else. This is what it looks like. Now for the occlusion, I feel like this is what sets this rig apart from others, because it does naturally fade when the light moves behind another object. And the way I did that, let's go into the Flare Composer and into geometry nodes. I know I'm going pretty fast, but I want to fit all this into one video. It happens after these elements. So every element is combined, and then it goes into this post-processing. What happens here? Well, first, it just stores that distance value that I keep using, the distance between the empties. Then it does the hit scan, which is, does it hit an object? And then we do scale elements to camera, which is, if we go into the modifiers here, we just have a scale to camera value where we can scale everything to and from the camera just like with the rig. Now, how does this thing work? It takes the occlusion collection and it pulls it into here. It realizes those instances, that's important, and then it raycasts towards that object. What does it raycast from? It raycasts from this light object. What's that? That is the ball over here that is emitting the light. It's this. This is what is casting rays. And so every single point on this ball which emits light is sending a ray towards the camera. Every single one. So there are hundreds of rays being cast right towards the camera. If they miss that box, then it registers as a 0. And if it hits that box, it registers as a 1. And so you get hundreds of 1, 1, 1, 1, 0, 0, 0, 1, 1, 0. And then we can do a statistical analysis of that to figure out how much of this ball is occluded. From 0% to 100%. And that's exactly what this is doing. Here I'm calculating that direction towards the camera from each point, and if it is hit, it goes into a statistic figuring out the mean value. And we take 1 and subtract that, which inverts it, so that instead of looking for how many are not hit, we're looking for how many are hit. And that is the occlusion value going out here. How much of it is occluded. And the only thing occluding is not just this object here, which you can replace with your own, but it's also a passpartout right around the camera. This thing. This is also an occlusion object, making sure that if the light goes far enough outside the camera, it'll also kill it. And this has a shape key on it that you can use to either shrink it so that it reacts just as the light goes beyond the frame, like that, or you can open it up a bit. How long have I been recording for? Oh, there's one more thing I want to show you, the ring of fire effect. That's this one, I'll put it on screen now. That is not made the same way that everything else is, but let me open that file for you. This is the ring of fire file. It is so damn simple. What we have here is we have the camera looking through a tube. And that tube has a funky material on it. It just has a principled BSDF with different colors for base color, specular tint, clear coat, and sheen. And that is what gives this that funky look with a bunch of different colors. There's one more thing actually. You want irregularities. surface imperfections, right? But you can get those in the lens flare as well. And this is basically, it's a map, a lens bouquet map inside of this node group. And it's just this, it's just a JPEG with some mapping coordinates to UV map them to the circles going into an image texture with the boost slider to make up for the darkening effect that multiplying it into the color has. But there is an issue with this, because I wanted to set this up the way I did with all the other sliders, so that you control it using a texture slider in the lens element geometry node. However, this is the bug that I mentioned earlier. What I would usually do, right, is I would hook up this slider to an attribute, and then I would go into the material and hook it up. But it behaves very weirdly, because things get dark and they stop working, and then when I mute it, it doesn't start working again until I mute this too, and it's just a mess. So the way I've solved this is I just do it globally in the material. You don't have a per element slider. You have to do it for the whole material, and that's fine because that's what it usually would be like. I'd prefer you have the control, but I'll ship it like this. If you know the solution to this, I really want to hear it. Okay, yet another thing, sorry about this, but there's a common bug that you probably will encounter if you use this, but it's easy to fix. If things start just skipping around like this, it probably still works when you move the camera around, but it's a bit annoying when you adjust parameters. So how to solve this is turn down the edge rounding. I don't know why this is incompatible with a couple of the other sliders. Usually when you just turn it down to about 0.8 or something, that'll fix it. I think it has something to do with the calculation of UVs. I'd love a solution to this if you have one, but it's easy to fix. Now, I know that was a lot. I tried to make a tutorial out of this, but it wasn't feasible. But I have put this up on my Gumroad. You can download the file, you can poke around, or I think that I've given you everything you need to be able to reconstruct this yourself. Anyway, if you stuck around this far, I'm impressed. I hope you got something out of this. And I'll see you for the next video.